All right, so we will get started in just one more minute here. But welcome all to our AMS Weather Band webinar on lake effect snow. My name is Tiernan, and we are incredibly excited to have Erik Heden here to speak to us all about lake effect snow. Erik is the Warning Coordination Meteorologist with the National Weather Service in Morehead City, North Carolina, where he works as the liaison between the National Weather Service and the public across Eastern North Carolina. He's been with the National Weather Service for 13 years. He worked previously at local weather service offices in Binghamton, New York, and Wilmington, North Carolina. But prior to his career with the Weather Service, he was a broadcast meteorologist for 5 years for various cities in upstate New York. And he received his degree in meteorology from SUNY Oswego. So he is an expert on lake effect snow, and we are very excited to have him here to share his expertise with us. So just one housekeeping detail here. If you have any questions, please put them in the Q&A section of the Zoom interface. We will be keeping track of that, and Erik will have a chance to answer questions at the end of the presentation. So I think that's about it. Without further ado, I'll hand it over to you, Erik.
All right, thank you so much. The presentation itself will be about 45 minutes. And again, just be sure to ask any questions you have throughout the presentation. I did go to SUNY Oswego, so I had to sneak some of those pictures in. I'll talk about why I chose SUNY Oswego, but this is one good example right here is lake effect snow. As she mentioned, I am the Warning Coordination Meteorologist down in Morehead City, North Carolina. I always tease people that's as far east as you can go in terms of National Weather Service offices before you hit the Atlantic Ocean. So why is somebody speaking about lake effect snow that lives down in North Carolina? I'll explain that in a second. Talk a little bit about my career, how I got where I am now. A lot of that is with regards to snow. The main crux of the presentation is certainly going to be about lake effect snow. Where does it occur? How do we forecast it? We'll also talk about some historic lake effect events. Since I am part of the National Weather Service, our big mission is protection of life and property. Since this is a winter talk, we will go over some preparedness tips on things like cold and snow and travel. And for those that are interested in meteorology, perhaps as a career, you're really going to want to stick around for the whole thing for sure. But the end of the talk, we're going to talk about who the Weather Service is, what we do, how we do things, but also careers in meteorology. We're going to give you some advice, some tips that you can really use at any point in your career, whether you're a high school student watching this, somebody in college thinking about going back to school, or even at the middle part of your career, some tips for success in the atmospheric sciences. So why is the WCM from Eastern North Carolina talking about snow? I love snow. Ever since I grew up, that's what got me into the weather. I live just south of Baltimore, so I've experienced the blizzard of '93, blizzard of '96. So I was used to snow. It's how I picked going to school in upstate New York. I really enjoy the snow. This is me on our weather building up in Oswego. These are from pictures of the Tug Hill trips we used to take as a meteorology club. And even my license plate in New York State at one point was LK effect for lake effect snow. So snow is my passion. It certainly is what got me into the career of meteorology. When I was in high school, the guidance counselor mentioned that there was, an actual degree in meteorology. So I pursued that. And initially, my biggest interest was in television. I started off in Syracuse, New York. I've worked in Binghamton, New York, and also Plattsburgh. Did TV for about 5 years. Loved TV. Really enjoyed the job day in and day out. But then after about 5 years, I realized that the Weather Service was much more stable in terms of meteorology. Once you're into the Weather Service, it's a rewarding career. It's very stable in terms of maintaining your job. Still kept my love of snow. This is a rare snow we had down in Wilmington, the office that got started off. And then more recently, we've had hurricanes Dorian and Florence. So that's definitely our big deal down here. The reason why I show you the career one, you are all here because you have a passion for meteorology, or I roped you into coming to this talk. But most of us, we all have a passion for meteorology. And for some of you, it might be a hobby, and that's okay. And for some of you, it's a career. Whatever you're passionate about, pursue it. My job is tough day to day, rotating shifts, working holidays and weekends, but I love my job. Doesn't mean that I don't have bad days, but the point of these slides is to show whatever your passion is, follow it, whether it's a hobby or eventually a career. because it'll make your life very, very exciting if you get to do what you love. So the talk is pretty much all about lake effect snow. We're going to show you some examples about how lake effect snow forms. And one of the best diagrams, and a pretty noteworthy one, is just talking about cold air crossing relatively warm bodies of water. 13 degrees Celsius is a magic number that we look for the temperature difference between the lake and about 5,000 feet. We'll talk about that in a second. But this is our basic diagram. On the far left is cold air. We don't really make ice cubes anymore, but if you still have those ice cube trays, when you put them in your freezer, you kind of see the steam. Same type of process. That water in the ice cube tray is relatively warmer. So on this diagram, your warm lake water could be in the 40s or even 30s in the wintertime. It's not warm enough that you'll go swimming, but it does warm the air above it. As that air warms, it rises, cools, and condenses, and you can get some lake effect clouds. If the process continues and the clouds continue to grow, you can have moisture in the form of lake effect rain or snow that develops over the lake. And eventually, that heavier precipitation is deposited downwind of the lake as heavy rain or snow. That's a simplified version. All you really need to know is cold air crossing a relatively long lake body, at least about 40 miles in length, can produce lake effect precipitation. A lot of other factors go into it: topography, convergence on the lake. Do you already have moisture? What's the wind direction? So we'll go through some of those different attributes here coming up, but that's the basic premise of lake effect snow. Throughout this presentation, I want to back things up with visuals, and nothing beats the 2014 snowstorm in Buffalo. They had over 5 feet of snow just south of town. This is an amazing time lapse showing the process. Moisture being picked up from the lake. You can see the rising air. This is snowfall. These are lake effect clouds and snow. And the other thing to point out, notice where the camera is, nothing's happening. With intense lake effect snow, some folks get a tremendous amount of snow, and then just miles down the road, other folks can see feet of snow. So that's a pretty cool video to show that process on that prior slide of cold air crossing relatively warm lake waters. I say lake waters because that's where most of our snow is our greater lakes, the Great Lakes, and that's where our focus will be. But I would be remiss if I didn't point out that we can get these types of phenomenon across the country. Really, any small body of water that's long enough, about 40 miles in length, and has cold air can produce precipitation. So again, we're going to focus on the Great Lakes, but there are some exceptions: the Delaware Bay, the Chesapeake Bay, and the Finger Lakes of New York are another one to point out. It's a relatively small lake chain, about 11 lakes in upstate New York, roughly oriented from north to south, kind of north-northwest to south-southeast. And this is a radar out of Binghamton. You can see these fingers of snow coming off the lakes themselves. Them alone, the lakes themselves can generate lake effect snow, and they're certainly enhanced by having some moisture added to the whole system from Lake Ontario. Usually localized lake effect snow off the Finger Lakes, not a huge deal. But in November 2016, I was actually up in Binghamton at the time. This combined with some synoptic moisture did produce at the time the second all-time snow in Binghamton. Of course, Binghamton's been in the news. They recently had around 39, 40 inches, and they had a tremendous amount of snow in March 2017. But again, at the time, that was a pretty big snow for the Binghamton area. I mentioned other types of lake effect. In this case, it's bay effect. It can happen across the Delaware Bay. You can kind of see a streamer in the upper right corner of this graphic. The more prominent one is this bay band of snow, or in this case, clouds, coming out of the Chesapeake Bay, January of 2018. Occasionally, we can get some accumulations in the Norfolk or Tidewater, Virginia Beach area, even the Outer Banks. I would say 2 to 4 times a year, we at least see cloud streamers from this. In fact, it just happened on the end of last week. We were cold enough to get some bay effect clouds. So it can happen throughout the country, but our main focus is certainly going to be on the Great Lakes because that's where we see the most prominent heavy lake effect snow. This is an awesome image of seasonal snowfall. It goes back to the end of last September, and it goes to the end of this September for this year. This does not, again, include any of the snow that recently fell up in the Northeast. You'll notice that the Rockies and the mountains out west kind of jump off the screen. But notice these other areas downwind of the Great Lakes traditionally have some of the highest amounts. Really east of the Rocky Mountains, these lake effect snow belts are where we see the highest amounts of snow. In some cases, more than 10 feet of snow. And you might say, well, Eric, maybe you just picked this year and it was a good year. You can look back, and while amounts vary, they tend to see a tremendous amount of snow each year. And often these are the snowiest places east of the Rockies seasonally that have the highest amounts of snow. Can you have a nor'easter that produces a lot of snow? Yes, but year in and year out, the lake effect belts usually see the most. We're going to show you a couple different locations that tend to see a lot. Again, the graph on the left shows you we're not talking inches, feet. I mean, just put that in perspective. You know, a normal size basketball hoop is 10 feet tall. Anywhere that you see in this purple shading averages more than 10 feet of snow, or at least in this past year they got it. This is a UP of Michigan. They tend to get a lot of what we call nickel and dime snow, multi-bands, a spray of snow, not single intense bands, but nonetheless, if you average over 200 inches of snow a year, you're certainly in a lake effect snow belt. The one that I'll probably focus on the most, because I'm most familiar, having worked up in New York State and gone to school there, are the ones east of Lake Ontario and Erie. These do tend to be the most prolific bands of snow. We'll talk about that in a second, but usually a couple times a year, you'll get an event with 2 to 4 inch per hour snowfall rates. And the highest amounts overall occur just east of Lake Ontario. The reason for that, Lake Erie usually freezes over. It's a more shallow Great Lake. So as early as December or even early January, the lake effect machine can shut off. So usually you see the highest amounts just east of Lake Ontario. The last place I'm going to mention is lake effect and also enhanced snow because of the topography. The Appalachian Mountains from southwest Pennsylvania down through western Maryland, West Virginia, even in my home state for now of North Carolina. I've taken a trip out toward Beech Mountain, Blowing Rock area, just west of Boone, North Carolina, can get a tremendous amount of snow. Roan Mountain, Tennessee, those types of places because of lake enhancement and the topography. So that really enhances some of that activity. And it's important to point out, it can obviously be a major disruption of transportation, but it's also a big source of the economy. A lot of the ski resorts south of Buffalo, they're there because they're in a snow belt. So it's a tremendous boom to the economy overall. But again, day to day can certainly impact travel when it happens. Without going into lake effect any further, we need to talk about the season itself, because there are certain months of the year that the lake effect can happen, and you might automatically assume winter. That's part of it, but that's not the whole season. And I appreciate Tom Niziol. He worked a long time with the National Weather Service in Buffalo. This is kind of an oldie but a goodie, an old graphic that we're going to kind of dice up and show you what we mean by that. This graph, anywhere you see this blue line, that's the lake temperature. Anywhere you see this red line, that's the air temperature. And our months are going from January to December. And what we want to focus in on is the start of the lake effect season. That's in August or into September. At that time, the lake temperature, the air temperature itself is colder than the lake. So anytime that starts to happen, you can start the lake effect season. So the lake effect season actually starts as early as August. We've had the first week in August, we've had lake effect in New York State and the Great Lakes as lake effect rain. And again, it's because the air temperature, this red line, is colder than the lake. Now, early in the season, we're not cold enough for snow. So we get lake effect rain, August, September, maybe even into October. Eventually, as we head into as early as late October, but more traditionally November, December, again, our lake temperature is cooling, our air temperature is cooling, but now we're getting cold enough that any precipitation that falls is in the form of snow. And that's when the real snow season starts, November and December. But again, when we're talking about the lake effect season, don't be surprised if you see lake clouds and even precipitation as early as August. The real meat of the season is usually around Christmas into the first couple weeks of February. Again, I just kind of divided this map up. Here's January and February. Again, our red line is the air temperature. We're much colder than the lake. This is traditionally when we can get some of our historic events. We've had some big ones in November. Historically, they tend to be big because they've had disruption to travel very early in the season. But when we're talking about the highest amounts, they tend to be in the middle part of December through the first week of February. Eventually, February, March, lake effect season continues, except for Lake Erie. That's when the lake starts to freeze over. and we can, either lose lake effect altogether or kind of limits how much can happen. So we'll widen back out. Again, we're on the graph. We're right here after our frozen lake. Eventually, April, May, and June, notice that the air temperature starts to warm up and the lake temperature starts to warm up, but the air is warmer. Lakes have a really high heat capacity. Water in general does. So it takes a long time for them to cool off, but it takes a long time for them to warm up. And this is our stable season, roughly from spring through the middle part of summer. Air temperatures are warmer than the lake, and we don't get precipitation. So the whole thing to get out of that is lake effect can start as early as August. Traditionally, November through February is the worst part of the season in terms of the highest amounts. We've talked about lake temperatures and temperatures in general a lot because without it, you're just not going to get lake effect snow. Before you even worry about what is the wind direction, do we have moisture, how high is the inversion, any of those factors, it has to be cold enough. If you're not cold enough, you're just not going to see it. So this is a simplified graphic from the beginning. Again, same concept, cold air crossing a relatively warm body of water. That water heats up the air above it. Warm air rises, it cools and condenses, forms clouds, and eventually precipitation. Now I'm going to start talking about how we forecast that. We certainly need to know the lake temperature. And I mentioned earlier, we roughly look for about 13 degrees Celsius change between what the surface temperature is of the water and about 850 millibars, which is about 5,000 feet. So in this made-up example, if our lake temperature is around 40, we would need 850 millibar temperatures around -9 or -10. That would, produce lake effect precipitation. If we have really extreme differences, this is most likely in the winter. Or in the early part of winter. I've been lucky to see it a couple times. We can get lightning in the intense bands. And keep in mind, November, December, that lake temperature could be well into the 40s. So you can have some extreme differences between the lake and the air temperature for the first part of the season. So we can look at the computer models to see what is our temperature at 850. We can look at the GFS, European, whatever model that you want to look at. But you need to know what the temperature of the lake is. This is an example from a couple weeks ago. If you look really carefully at the numbers, 43, 40, 41, generally speaking, on this day, our lake temperature was in the lower 40s. So we would need temperatures, in -9, -10 at 850 to be cold enough for lake effect snow. So that just gives you an example as a forecaster. What is the temperature of the lake? And do we have cold enough air at 850 millibars? And any winter weather fan is kind of looking at that and knows what the threshold is. Now that we've established that we're cold enough, where is it going to go? What is the wind direction? That will determine where the lake effect band will set up. These are some examples from the upper Great Lakes. A northwest wind crossing Lake Superior, again, tends to produce multiple bands of snow on the UP of Michigan, downwind of the lake. This is an example for Lake Michigan. A north wind would produce snow south of the lake, again, downwind of the lake, places like South Bend, Indiana, southwest lower Michigan, those types of areas. So the wind direction is extremely important. Meteorology is very, very tough. And if you are a football fan or a sports fan, they're always talking about games are a matter of inches. With forecasting, it's often just a matter of miles. Just a 10-degree shift of the wind direction can make a huge difference. And the difference between a west-southwest wind and a west wind, in the whole scheme of things, that's nothing. That's very minute in terms of forecasting. On a normal day, if it's 80 degrees in the summer, you don't really care about the wind direction. But that difference in wind direction could be the difference between Buffalo, a major city, getting snow and it staying south in the suburbs. So it makes a huge difference knowing what the wind direction is. And it's also important to know, how does that wind vary, or how does the wind not vary? If the wind is from the same direction from a long period of time, it's going to be very, very localized, the snow, but very intense because it's going to be over the same area over and over again. If that wind varies northwest to west to southwest, back to northwest, you get the fire hose effect where it's kind of spraying the whole area with snow. And it may not be intense in any one area, but you kind of get a general snow everywhere. So wind is important to know where the lake effect sets up and who is actually impacted. And the one thing we don't cover too much, but the residence time over the lake, if it's super windy, it can also limit snow potential. If it's too windy, it just means that you don't have enough time to pick up moisture over the lakes. So since we're talking about wind direction, it's really important to mention fetch when you're talking about lake effect snow. And that just refers to how long of the lake does it go over? How much of the axis of the lake does it go over on that wind direction? And a lot of us know certain cities need a certain wind direction. I went to school in Oswego, we were 285, 290. Syracuse, a 300-degree wind. Tug Hill Plateau, a 270-degree wind. So local meteorologists or people that are familiar with the area kind of know these. And we'll show you two examples to reinforce that. This is Buffalo, New York, in the western part of New York. They can get snow off of Lake Ontario on a northeast wind, a northwest wind, or west-northwest wind. But notice the red lines are really short. Those are short segments because it's barely crossing Lake Ontario, so not really a big deal. On a northwest wind, they can have snow from Georgian Bay and Lake Huron, but the lakes are so far away, they usually don't see prolific snows from upstream lakes. Now, on a southwest wind, notice how long this red line is. The whole length of Lake Erie can be realized with a southwest wind, and that's why the southwest wind is the best wind direction for heavy snow and off of Lake Erie for Buffalo. In addition, the lake converges toward the end, so you can get some additional convergence. So we look at the fetch all the time. A longer fetch tends to produce more intense single bands. A weaker fetch or a shorter fetch tends to produce multiple bands. The same thing off of Lake Ontario. Again, the best fetch would be the entire length of the lake. That would be a 270-degree wind or west wind, very, very intense snows. As you get into a northwest wind or even a north wind, can you get snows in Syracuse or Point South? Yes. Can you get snow throughout the Finger Lakes? Yes. But they tend to be weaker, and it still might be 6 to 12 inches. It's not that it's not a lot of snow, but compared to 3 to 5 feet, it's much weaker than a longer fetch type of band. One important thing to point out from this graphic, and we'll emphasize it with some soundings coming up, anytime we can get some additional moisture from upstream lakes, that can really add to our snowfall totals. Some of the bigger events have certainly included that. So now that we know fetch and wind direction, we can kind of put together a climatology. And again, these are years and years in the making. This is an example. I thought it was really well drawn out. I have zero experience up in northern lower Michigan, but I thought the Gaylord office had a great example of this. This is a typical northwest flow for them, again, 310 to 320 degrees. These are lines where the band would set up or showing that they would cross Lake Superior. And notice 150, 160, 150 miles. This is the fetch across the lake itself until it reaches this area. So with that 160-mile fetch and then another 70 across the northern part of Lake Michigan, that's where they tend to get their heaviest snows. And then where they get lighter lake effect snows, notice they just have a short 70 or 80-mile fetch off of Lake Michigan. So I thought this was a good graphic because it can show you, based on known wind directions, we know where the snow belts are. And when we look at models, we can equate this wind direction with who will probably be impacted. Of course, the million-dollar question is, what will the wind direction actually be? When you're talking forecasting with any regard, you got to talk with how we analyze the current data. You're not going to get the forecast right down the road unless you have a good measure for what's happening now, what's happening on the ground, and also what's happening in the air above you. So because of that, we launch weather balloons twice a day all over the world, measure things like temperature and dew point and winds. This is an example in the upper right, what the weather balloon looks like. This is the parachute that's attached to it. And then that's what's called the radiosonde, which is the instrument package that actually has the temperature and the humidity and things, the sensors on it. This is me doing a weather balloon launch here down in Morehead City. We're one of the offices that do it. Takes about 15 to 20 minutes to fill it up. We use hydrogen at our office. We actually generate our own. Some offices use helium. And they can get as high as 110,000 feet. They're constantly analyzing that data as they're going up. And they're crucial for forecasting. Prior to Florence, prior to a big ice storm or winter storm or severe weather outbreak, we in the Weather Service will launch additional weather balloons because, again, all that data goes into our forecast. And it's really important to know what's happening above us to make any predictions. The reason why I showed you that weather balloon is this is what comes out of it. This is called a forecast sounding or a sounding. It could be either what has been measured by the weather balloon, or then what a model will generate will happen in the future. Just for those fans at home, on the bottom is temperatures. So we're going from negative 40 to plus 40. These are wind speed and wind direction with the wind barbs. And then we're going from the ground, the surface, near 1,000 millibars, up into the atmosphere. So 700 millibars, about 10,000 feet. One other thing I want to point out is there's two black lines on here. The one on the far right is temperature. So how does the temperature change from where we live at the ground, high up in the atmosphere? And the other one is dew point. Very, very important. You can get all kinds of stuff from the sounding. But for our basic purposes, anytime these lines come near each other, that shows humidity or moisture. It's a very moist atmosphere, and we have clouds. Anytime these lines are far, far apart, very, very dry and a lack of clouds. So in a split second, any forecaster can look at that sounding and say, hey, we're dry above about 700 millibars or 10,000 feet. Below that, we have plenty of moisture. So we're going to talk a little bit more about how this can come in play with regards to something that's called a capping inversion. So remember, this far right line is the temperature line. As you go up in the atmosphere, you usually cool with height. The sun heats the ground, and the ground heats the air above it. So anytime you're farther away from the ground, you're cooler. When you've hiked up a mountain, when you've flown a plane, anytime you're higher up in the atmosphere, you usually cool. And that's what's showed by this graphic right here. As we go up to about 700 millibars, we are cooling. Whenever you warm with height, we call that an inversion, and we mark this with a red line on here. On a sounding, anytime you go from left to right, you are warming with height, and that's called an inversion. This is really important with lake effect snow. We call this a capping inversion. Basically, this is the limit that clouds can grow. So in this case, it's about 700 millibars or 10,000 feet. For you severe weather fans, or if you're watching from the Central Plains, you must think 10,000 feet, that's nothing. You're right. Lake effect snow is a mesoscale process, very, very low to the ground. 10,000 feet is actually really, really good. For severe weather, we're talking 30, 40, 60,000 feet tall, but lake effect snow is very, very shallow. On average, it's probably closer to 5,000 feet, and it can be as low as a couple thousand feet. But the deeper you have, the more flakes you can grow and the heavier snow you can produce. So we look at the height, and we call that the capping inversion. It's very, very important how high that is. The higher it is, the better for snowfall. In that layer from the ground up to the capping inversion, we look at the shear in the environment. If you're a severe weather fan, you want shear. If you're a lake effect fan, you do not want shear. So in this same example, again, this is from the 2014 event. We're going to show you pictures and radar, all kinds of stuff of this event. From about the top of the cap to just above the surface, our wind is basically out of the west-southwest. So very, very little shear. In these cases, you have healthy bands that are intense and single bands. This is the best scenario in terms of lake effect if you like heavy snow. So we mentioned the lake effect event of 2014. Here's a loop out of the Buffalo radar. And you might say, well, yeah, that's impressive. This is over 24 hours, and you're talking about many, many inches per hour that's snowing. So when you have little shear and the wind is not varying a lot with time, that lake effect snow is going to stay over the same place. And again, this event produced over 5 feet of snow. Very, very impressive. We'll go back to another similar sounding. This is a different event. This is in December of 2019. So this time last year, same type of thing. We've got a capping inversion, around 7,000 feet or around 700 millibars. But notice these winds, southeast at the surface, southwest, and then due west up near the cap itself. So veering with height is good for severe weather, but not so much with lake effect snow. If we see this type of sounding, that usually means that we're going to get a multi-band or real sheared lake effect snow. In some cases, it's so strong we don't even see it, but you can see off of Lake Ontario, these multiple bands will form, and also off of Lake Erie. So we've got a band here, and then kind of a spray, a real, real wide band. You might say, well, multiple bands, multi means more, better, right? Well, it just kind of spreads out the snow everywhere. So again, it's not quite as intense. It's what they see more up across the northern part of Lower Michigan and the UP. With that wind shear, we just don't see quite as much snow. Last thing I want to show you, we mentioned wind shear, we mentioned capping inversion. We also want to look at the moisture. This is a great example of a very moist sounding. With the process itself, you're picking up moisture off the lakes. But if you say, let's say you have a storm that goes by and there's a lot of wraparound moisture with it, that's going to enhance the snowfall, especially if we get that snow in a special layer. This is our snow growth area between -10 and -20. On this graph, here's our -10 line, and here's our -20 line. So we certainly have moisture in that layer. That's where you get those big fat flakes that accumulate really, really quick. Very, very efficient snow. And if you have moisture and lift in that layer, you can get some impressive snowfall totals. So moisture is important as well. You can see all of this, these streamers coming. You know, it doesn't just start at Lake Ontario, Michigan, Superior, upstream across Lake Huron and Georgian Bay. You can just see all this moisture coming in. So really impressive when you can get all that stuff to match together. So I want to show you an example how we forecast this, because I talked about a lot of stuff, and a lot is known about lake effect snow. But as a meteorologist, how in the world am I going to track, he said, the capping inversion, wind shear, wind direction, moisture, dendritic layer, -10 to -20? How am I going to know all that? Thanks to a program called BuffKit, we can look at that. It's been around forever, back to when I was in college in the early 2000s. We were taught how to use BuffKit. A lot of forecasters are probably familiar with it. You can use it for severe weather, freezing rain. What's the wind gust going to be tomorrow? Temperatures, fog forecasting, stratus forecasting. It's phenomenal. But you might not realize why it is BuffKit. If you click on the Lake Effect tab, you can turn on a lot of different features. So the example we're going to use, thanks to John Hitchcock from the Weather Service in Buffalo, sent me the NAM model from the 2014 event. So I looked it up. Lake temperature is 48. So you have these up and down bars that you can adjust the lake temperature. And then this is the NAM. So it'll give you what the 850 millibar temperature is. And we can see we have a difference of 24. Remember, the magic number is 13, so almost double that. So very, very extreme instability. So we know we're cold enough. What are some other things we wanted to know? The wind. Where is this band going to set up? So here's our capping inversion. Again, it's better on this sounding. Red is our temperature line. Anytime it goes to the right, here's our inversion. So I can set these little white bars here, these sigma levels. I can set those so they measure the mean wind between the ground and the top of that inversion. And that will give us a wind direction. So in this case, it's about 260 degrees. And that's where these green boxes are. So the model predicts that the lake effect band will be about here. I'm going to go forward one slide and then back to show you the evolution. So with BuffKit, you can go forward in time, back in time, forward in time. You can see how the band shifts. Now the wind is about 244 degrees. With that more of a southwest wind, that would be up near Buffalo, if not the north suburbs. So again, you can go hour by hour, any model you want, the HER, the NAM, GFS, whatever you want. So really neat stuff. Next thing I want to show you, again, here's our inversion. We know it's pretty high. And then we also mentioned, is it moist? Yes. And then how about the winds? Are they uniform? Yes. These boxes here, these bands, will highlight yellow if there's moderate shear and red if there's extreme shear. So all of this is in BuffKit, and we use that heavily for forecasting. At least we did back when I was in Binghamton. I'm sure there's other stuff now. So very, very impressive program. For you weather enthusiasts and others watching from home, you can download this for free today. So it's nothing that costs anything. And I should point out, we're a little bit past 3:30. We may have some new folks joining. If anything is uncertain, if you have any questions, ask it, and we will take questions at the end. So we're a little bit more than halfway. So just hang tight and ask your questions, and we'll certainly get to them. And for those that are just joining, don't forget, after the lake effect session, we're going to do a quick thing on careers, which is very, very important. One more thing to point out, BuffKit's been around forever, but since I've been in the Weather Service, it's amazing the models, the high resolution models that have come out, hourly data. We've got the 3-kilometer NAM, the Canadian GEM, NMM, ARW, so really, really good stuff. And this has changed just since I left Binghamton not too long ago. I talked to one of the forecasters. I mentioned John Hitchcock out in Buffalo, and he mentioned that these high-res models can really show us realistically where the lake effect snow can be. But it's still very important to have that human component, the forecaster in the office. He mentioned they've noticed, especially off of Ontario and Erie, that the models kind of have the band about 5 to 10 miles too far south. And if you're watching from home, you might say, man, that's pretty darn close. And it is, that's good. But again, the difference between downtown Buffalo and the southern suburbs is not much, or downtown Syracuse and Pulaski or east of Lake Ontario. So it still pays to have experience, and knowing, model biases is very, very important. So I hope you got a good understanding of lake effect snow. It's all about the temperature. It's got to be 13 degrees cooler at about 5,000 feet Celsius. Then the lake water temperature can start as early as August, but the real snow season is November through February. The wind will show us where it goes. If you have little shear, a lot of moisture, and a really high inversion, you can get big, big snows. That was usually the case pretty much in all these scenarios I'm going to show you. And a big shout out to the Weather Service in Buffalo. They've been doing this for years and years and years, tracking storms, naming the storms in the past, and for historical purposes, so they could rank them and identify them. They redid their page. They've got radar data, 500 millibar data, snow reports. Just kudos to that office. I know John said it was a big team that worked on it. You all did a fantastic job. So I'm going to go through a couple of the big events. This is last year, 2020. This was kind of a lake effect blizzard is how they described it. One of the big ones with this was very, very gusty winds. This is a band across the eastern end of Lake Ontario. This is a radar here. The black dot is Montague, New York. So persistent snow, 3 to 4 inches per hour. And with lake effect snow, you usually have really strong winds coming into the band and converging. So it can be breezy. My time in Oswego was certainly windy, but to have blizzard-like conditions, at least with regards to wind, doesn't happen super often. Visibility, yes. I mean, a true whiteout is lake effect snow. I think next to the high snow amounts, the most impressive thing is probably the lack of visibility. But this got national news because the lakes were elevated, and because of that wind, they had a lot of freezing spray down in Hamburg, New York, and actually encased some of the houses along the lakeshore. So certainly got some national notoriety. These snowfall amounts, pretty impressive, over 3 feet on the Tug Hill and Lorraine and Croghan, those areas, over 3 feet of snow east of Lake Ontario. And these are our traditional snow belts. Can Watertown get it? Yes. But traditionally, the highest amounts are south of Watertown and in the ski towns south of Buffalo. And you're going to notice a theme here. Apologize to anybody watching from the UP of Michigan or other areas. You get a lot of snow on a average basis, but my expertise is certainly in New York, and that does line up with the most historic storms in terms of lake effect. The event I showed you in the beginning, that time lapse, a beautiful picture of this lake effect band. Again, that's one of the really neat things. It's not neat if you're a snow lover and it's north of you and you're looking at this wishing the snow was over you, but you can be completely sunny or even some dark skies, but in the distance is the lake effect snow, and it goes from 10 miles visibility to 0. I mean, true lake effect snow is whiteout snow. This event, I showed you the sounding and that time lapse. It produced over 5 feet of snow just south of Buffalo. These are some pictures of the event itself. This is the New York State Thruway. The Thruway itself was actually closed from the New York PA line up to Rochester. So a huge section of the Thruway was shut down. And one thing you don't see that often, there's not a lot of moisture in lake effect snow. So it tends to not cause roof collapses and things like that. But this event did, and it's kind of attributed to how deep the snow was. So everybody will look at that and say, I mean, it's just unimaginable. 65 inches of snow. That's more than most people get in a season, if not multiple seasons. So right there, over 5 feet of snow, it's impressive. But the thing I want to point out to you, the amounts are impressive in lake effect snow. The poor visibility is impressive. And I think the third thing is the intensity and how it changes locally is impressive. So Cheektowaga, 4 miles south, was 65. Okay. The Buffalo Airport, a little bit north of there, 6 inches. All right. 3 miles north of Cheektowaga, 2 inches. So you have the town of Cheektowaga, 4 miles south, 65. 3 miles north, 2 inches. So very, very impressive. And that's when you get that same wind direction and it stays over the same location over and over again. Certainly can be impressive. This is February in 2007, 141 inches of snow. This was for a whole event. This actually got national press attention. Don't worry about the sound, but you might recognize this person on the right.
feet of snow. But as you try to walk into it, pretty difficult with over 5 feet of snow. It's noticeable.
So it got national attention. At the time, I was in Plattsburgh, New York, which was 3 hours to the northeast. And I'll never forget my news director asking if I wanted to go down there. And they knew I was crazy about snow, but that wasn't our area of coverage. So I thought they were teasing me, but they were serious. They sent me down to Pulaski, and I saw that snowstorm event. So very, very impressive. Got huge national attention. All the major networks were up there. Oswego, Pulaski, and just south of Watertown. Tremendous amount of snow. We're going to talk about this in a second. It set an unofficial record for event in Redfield at 141. But again, just tremendous amount of snow. As you know, when you have lower amounts of just over 3 feet in East Aurora, that was a pretty big event at 141. So just very, very impressive event. And it was most noted, yes, for the amounts, but the longevity to have that long of event to produce that amount of snow is historic. Another one was in late 2001 into 2002. This is one, I was a kid in Maryland trying to go up to Buffalo to see this event. I wasn't able to. They had 81.6 inches of snow in Buffalo. One of the more memorable snows in Buffalo, caused a lot of issues with transportation. I was able to go up to the Tug Hill in early January 2002. I think I measured a snow depth of 40 or 50 inches. It was crazy. They didn't have much snow at the time prior to the event, so I could actually sink down into the snow pretty easily. And Montague is a well-known town. It's just across the central part or west central part of Lewis County, 127 inches of snow. One of the most famous ones is 1997. This area, again, east of Lake Ontario, saw 90 to 95 inches of snow, very, very impressive amounts. It unofficially had set a record at one point. I'll get to that in a second of Montague. But this is a picture from Montague on one of the many trips I've taken up there. Huge business up there for snowmobiles. You see, 30-to-1 ratio probably of snowmobilers to cars. So a lot of trails up there. There's a lot of seasonal homes, so folks are not up there in the wintertime. So on the edge of the Tug Hill, Redfield, New York, 141 inches. That's kind of the most in any one single event. We in the Weather Service define records as 24 hours, 48, kind of certain time specific. So this one was kind of hard to officially say a record, but in the records we've seen, that's the most we've seen from one event. The band kept shifting around, but it was pretty much the same band. So that's definitely impressive. I put 3 stars with this one. In some of the literature, you may see that there was a report on this one. The official record for snowfall is, I think it's Silver Lake, Colorado at 76 inches. Montague measured 77 in a 24-hour period. It's an unofficial measurement. They measured 6 times in a day instead of 4. When you have that much snow, if you measure more frequently, you're going to have a higher amount because it really compresses. I know my friends in the Binghamton area have seen this the last couple of days. When you get 40 inches of snow, it doesn't stay 40 for a while. It compresses under its own weight. Nonetheless, they had about a 51-inch snow depth change. So it was still probably a record for New York, but unofficial 77 for the 24-hour record. And then Hooker, New York, which is a town on the southwest part of Montague on the Tug Hill, almost 500 inches of snow. So again, the highest snow amounts east of the Rocky Mountains for sure, and most of them are east of Lake Ontario. So we're just about wrapping up. We're done the lake effect part. Please don't log off. Get your questions ready. If you've got any questions on the lake effect part, be sure to ask those. We're going to go through the preparedness stuff a little quick, but I really want to hammer home the career stuff because I think it's important. So when we're talking about preparedness, you can break it down into home, being in your vehicle, or outside. For home, having 3 to 5 days worth of food or medicine and water is important. For folks along the coast, I always say if you have your hurricane kit, you're good to go for the wintertime. And checking up on your heating system is important. Do you have a secondary way to heat? Have you done maintenance on it? Is it an older furnace that might need replacing? Those are certain things to consider. As far as the road goes, you definitely want to have your vehicle winterized. Is your tire tread good? If you're up north, do you have snow tires? Those types of things are important, having windshield wiper fluid. But one of the most important things, in addition to having an emergency kit, checking the forecast. It seems really easy, but if you have some flexibility in your travel plans, you can usually avoid it. Think about the storm we just had in Binghamton. If you could avoid about a 36 to 48 hour period, allow them to clean up, you can completely miss that event with regards to the road. So you can usually plan around these events with your travel. If you are traveling, having an extra pair of gloves, hats, boots is a really good thing. And you might think about how you normally dress. If you just throw on a light jacket, you're going to the grocery store, you're going to work, what would you do if you broke down? You might not have a real thick jacket on because you say, well, I'm just going to be outside for 5 minutes. Having those extra things in your car can really make a difference, especially if you're stranded for a couple hours. And the last one, being outside, it's all about dressing in layers. I tease my kids, we're pretty much in the chilly section down here in North Carolina. Occasionally we can get extreme cold. Extra layers make a big difference. Think about your extremities. Having a hat, gloves, and thicker socks makes a difference. And if it's a really cold event, having those heat warmers, those packets in your gloves and also in your boots can make a big difference. So extra layers are probably one of the most important things with extreme cold. So at the very beginning, I mentioned meteorology as a career. I wanted to touch on that because who knows who's on these calls. And this will be recorded. So any people that are interested in the atmospheric sciences, now's the time to really pay attention. Meteorology as a career, a lot of times people think just TV. So the lady in the lower left is a broadcast meteorologist, and that's a big sector. But the Weather Service is over 4,000 employees. We employ the largest amount of meteorologists. So that's a big sector. Research, we need research meteorologists to learn more about lake effect snow, tornadoes, hurricanes. There's Mr. Mike Evans. He's a SUE up in Albany. This is a picture from the Binghamton area. So the Weather Service is also an avenue. So there's a lot of careers from energy to the private sector to the government for meteorology. So don't get too focused on any one. If you have an interest in meteorology, just explore what's out there. This is a poster I did at the National Weather Association conference in 2014. So it's an older poster, but it has some validity in terms of going forward. One of the biggest things I tell students, or really anybody in their career, even mid-career in the Weather Service, your willingness to move is probably your number one factor in deciding landing a job out of college or moving up. And you might say, well, what about grades and your work ethic and things you've done? All very important, very important. But if you're only willing to apply in your backyard, you're limiting your chances. If you have all those skills, good work ethic, I know GIS, I know programming, and I'm willing to move anywhere, you're going to move up very quickly. So keep that in mind for at least trying to break in and then where you want to move in your career. And that's going to require taking some risks. It's a big risk to live in another part of the country that you're not used to. When I was young and I got into TV, I was a part-time meteorologist, no health benefits. That's a big risk. But I knew working a couple months in weather, eventually with that experience, I would move up. Starting at a low salary for pay, starting in the private sector. Maybe you want to be a TV meteorologist or you want to work for the Weather Service. Starting at a local private company in the private sector can get you experience, and maybe you like it and you stay, maybe you move on. So those are all risks. Don't forget the power of networking. You have seen my presentation today. Send me an email. You have a question. Find somebody that's willing to help you and provide guidance. You are constantly networking. I always thought it meant coming up to somebody at a conference and talking, and it can, but it's all about relationships. You know me from this presentation. Have you gone to an AMS or NWA conference? Have you had an internship? Have you done a job shadow? If you've done those things, keep in touch with those folks. You don't have to email them all the time, but a couple of years down the road, hey, Mike, I'm here. This is what I'm doing. Just want to keep you updated. Meteorology is a small business and career. People in TV, private sector, and weather service all know each other, and that can be a good thing as you're moving up. Last thing I'll talk about is kind of seeing opportunities in your failures, being a good listener, and setting yourself apart. You want to challenge yourself. If you've never been to an AMS conference, go to an AMS conference. If you've been to a conference and you've never presented, present. Run for local office. If you're a weather enthusiast, try to do a webinar. Try to support AMS by doing talks. Always constantly try to challenge yourself. And if something doesn't work out, you don't get the job, you get passed over, you don't get the opportunity, learn from it. You usually don't learn much when everything's going your way and you get what you want. You learn from things when you don't get what you want, when you've made a mistake, and you have an area for improvement. And the last part is being a good listener. You are going to have mentors along the way, and you'll know because they may give you hard advice, but they're always looking out for you. So people that are encouraging and giving you advice, listen to them and definitely hold on to them. They may not be coworkers, they could be family, or they could be people from past jobs. So certainly remember that as you try to move up in the agency. Last two slides are going to be about the Weather Service. We're over 100 offices in the country. We do have national centers like the Storm Prediction Center, Hurricane Center, and also the Weather Prediction Center. I mentioned we're the largest employer of meteorologists, and there's a lot of career opportunities. It's not just forecasting, research, science, and also administration and management. So there's a lot of different things in the Weather Service beyond the forecast itself. Now, forecasting is our bread and butter. We're open 24/7, 365 days a year. This is our office, all of us but two during Florence. We were there for 3 days. This is my office. If you look carefully, you might see a lake effect plate on the wall and my water for the hurricane. We are reinforced buildings in the Weather Service. The coastal offices have hurricane shutters, so we're designed to stay there when the weather gets bad. In general, it's about 20 to 25 people for each office. And our main goal, protect life and property, enhance the national economy. So forecasting and warnings, that's our bread and butter. That's what we do. When the weather's quiet, you can mold the career into what you want. It's amazing. And it's one thing I didn't realize. I probably would have gone straight into the Weather Service instead of TV. So what I mean by that is when I was in Binghamton, New York, November through March, we were busy with the weather. Maybe I didn't do a lot of different things. But when the weather quieted down, I got to do outreach and school visits and Skywarn talks and go to AMS conferences and NWA conferences. So I had a lot of opportunity. I was an outreach person. If you're a research person, you can write papers, you can do journals. They will pay for you to go to conferences. Amazing opportunity. If you like computer programming, you can write code and improve operations with that aspect. So you really can mold the career into what you want. And it goes back to the beginning, taking a risk, trying to get in the Weather Service, maybe in an area or private sector where you're not accustomed to. That's just your start. You have a whole career to get to the city you want or to the office or location that you want. And the Weather Service does have good pay and benefits and security, which is all nice. It's nice to have stability for sure, but I can't express it enough. In the Weather Service, again, when the weather's quiet, could be an evening shift, could be the weekend, could be a season of the year where your location doesn't get a lot of weather. You can really mold it into the career you want. So don't forget that when you're considering applying places. So that is it. I know we covered a lot. We went from lake effect snow to careers, but anytime I have people that are enthusiastic about weather, I want to mention the Weather Service, but also want to mention the career aspect. You can always email me if you've got any questions. My email, eric.hayden@noaa.gov. I'm on Twitter a little bit, mainly just for weather. It's at Eric or at E. Hayden. And then for our local office, we're really big into education and outreach. So if you search us on Facebook, YouTube, Twitter, or now Instagram, it's just NWS Morehead City, and you can follow us there. So at this point, we will be happy to take any questions. If you missed that part in the beginning, if you've got any questions on anything from careers to the Weather Service to lake effect snow, I'll be happy to take those at any point.
Thanks so much, Eric. That was a fantastic and incredibly informative talk about lake effect snow and careers. We do have some questions, so I'd be happy to read those out for you here.
That'd be perfect.
Great. So first question is, what happens if freezing rain hits the water? Does the water freeze?
So when freezing rain hits a surface, it's got to be cold enough so it actually, freezing rain, when it makes contact with a cold surface, it freezes on contact. So usually if freezing rain were to hit water, it would just act like regular rain because the water would be above freezing. So freezing rain accumulates on other surfaces like power lines and cars and sidewalks. That's the type of precipitation that it freezes on contact. And with the water being above freezing, it would just act like raindrops going in it. Very, very good question.
All right, our next question is, does the depth of the water have any impact on lake effect snow?
I'm not entirely sure. I know like the Finger Lakes are deeper lakes, and Lake Ontario and Erie is a deep enough depth. I think it's more to do with the fetch itself. So like if you have a small pond or small lake, you know, in your local area, that's just not long enough fetch. So I think it's more to do with that. The biggest impact the depth would have would be on water temperatures. So sometimes you can have, you know, if you have a really deep lake, it will take a while to cool off and also warm up. So that can affect your season, either longer or shorter. So it can have some of those types of effect maybe on that, but not so much with lake effect per se. It's more about the fetch.
All right, the next one looks like we had some help from the audience as well, but I'll just read it out. One of the slides showed a fairly detailed map of lake temperatures. Are there numerous buoys or some other method in the Great Lakes that are recording temperature?
Yeah, and it's funny, that's a graphic that I used way back, even, you know, in the Binghamton days. And then within the Weather Service, I'm always unfamiliar with what's on the internet. And the Weather Service, we can look at satellite data and look at that. If you just Google, you know, lake temperatures, there are buoys out there. But buoys are, and I'm not as familiar with the Great Lakes, but I know down in my neck of the woods, sometimes they can be kind of spaced out and you want more of them. So more and more, we're using something called remote sensing from satellites to measure what the lake temperature is. So that example I showed you was from a cloudless day, and it showed, you know, pretty accurate the temperatures. So yes, there are buoys, but the remote sensing kind of fills in a lot of gaps. Awesome question.
All right, our next one is, I may have missed it. Directional shear is not conducive to lake effect, but what about speed shear?
So speed shear, I'm not as sure about that. I mean, we do have probably some speed shear in some of those lake effect environments because they tend to be some windy scenarios, but I'm not really sure about the effect on that. But the directional shear is definitely not good for it.
Great. And the next one is it the vertical motion in the snow band that enhances convergence?
So that is just the instability from the lake itself, but there's other factors that can enhance the convergence. One is just the layout of the lake. So I kind of mentioned it with Lake Erie. It's naturally funneled, and they can have some of the most intense snows. It's just that they don't last as long as Lake Ontario because of the ice cover. So you can get some convergence just on the shape of the lake itself, and then also different factors with topography can enhance the convergence as well. So yes, the lift because of the temperature difference, but also the layout of the lake itself can do it. And you see that with Lake Erie, it kind of funnels toward an arrowhead anyway, naturally.
Yeah, great. And then career question, what is your favorite part about your job?
Favorite part of the job is definitely mentoring people getting into atmospheric sciences, so school visits and just, you know, telling them about opportunities we have in the career of meteorology. Right along with my job is never the same. So when I was in Binghamton or here in Morehead City or Wilmington, the weather's always changing. So it makes it a very interesting job. Challenging, stressful sometimes. Some of the more boring periods of weather, then you can work on projects. So I would say definitely working with students of all level. So anybody interested in weather, and then just the fact that it's always changing. I mean, it's quiet today. We're clearing out, and it's, you know, not too much going on in our neck of the woods, but we're watching a big cold front for the end of the week. So there's always something coming.
That's fantastic. And we had one, oh, this is a comment, it looks like, from about the depth of the water has an effect if the lake freezes over. So
yes,
just,
yeah. So that can change the season, and you know, off of Lake Erie, that's one reason seasonally they don't see as much snow as like east of Lake Ontario because of the depth is more shallow, so they freeze over. Yep.
got it. All right, and another one has just come in. How far south or east can lake effect moisture travel to produce snow? For example, could moisture from Lake Michigan travel towards Indianapolis to produce snow?
100% for sure for Indianapolis. So lake effect snow, we'll go off of Lake Michigan. It approximately gets to the Appalachian Mountains. So Beach Mountain, the Tennessee, North Carolina line, the Appalachian Mountains, That's about where it stops. If those mountains weren't there, perhaps it could go even farther east. But you have to remember with a mountain chain, as the air goes up one side, really wrings out all the moisture. Air rises, it cools, condenses, a lot of precip. On the descending side, it dries out, it compresses, it heats. So we don't see too much lake effect snow east of the mountains, more because of the barrier. So for roughly along the spine of the mountains, can it go 10 or 20 miles east? Yes. And then farther in the northeast, the big cities, New York City, definitely Albany, it can get inland pretty far, depending if the winds are strong enough and there's other factors like if there's a lot of moisture around, then it can live longer. So yeah, many, many hundreds of miles it can go inland.
All right. Okay, that's our questions, and those were great questions as well. Thank you all for asking those, and of course, thank you, Erik, for that great talk and for sticking around to answer those questions. Really appreciate it. So
yeah, no problem. Thank everybody.
So that's the end of our webinar for today. For Weatherband members, it will be available to view on demand in about a week. So tell all your friends, give the gift of Weatherband, and thank you again so much, Erik, and thank you all for attending, and have just a wonderful holiday season.
Take care, everybody.
All right.